Okay, so this time we will begin a new chapter. We are still in mechanics, so we are still trying to solve problems involving motion. Tapos gusto natin malaman ano yung mga initial, final velocities, and any unknown value within the motion of objects. Now, previously, we have solved problems in motion using Newton's laws. Tapos the way we applied Newton's laws is we first try to identify the forces, tapos galing sa forces, we apply Newton's laws in order to solve unknowns doon sa motion ng object. Now, one thing to note here is that we are dealing with forces. Now, forces are vector quantities. So, one of the difficulty in using Newton's law is because we are dealing with vectors. Na yung addition, subtraction, and yung vector operations are not like what we've learned from elementary school when dealing with scalar. Now, we've seen that in Newton's laws na in order to add vectors, we need to consider the components. So, we subdivide each vector with component and so on. So, medyo mahaba-haba yung process in solving problems using vectors. So we will look at one alternative way of solving problems in mechanics. This is through work and energy. So the first thing that we will discuss in work and energy, we will convert yung forces that we have into work done. Now, work done in physics is a scalar quantity. So throughout this technique in solving problems in mechanics using work and energy, we will be dealing with scalar quantities. Which makes yung ating solving later easier compared to when we are dealing with vectors. So that is the advantage of using work and energy in solving problems in mechanics. So we will start by first defining what is work in physics. So first, let us consider this simple case here. So you have a person pushing the box with a force equal to F. Now, let's assume na itong force na ina-apply niya, this is constant. Tapos, while the person is pushing the box is moving to the right. So, this results to a displacement equal to S. Now, we will assume na yung path taken by the box is a straight line, such that our displacement is a line. Another thing that we have in this situation is that yung ating force and yung ating displacement are in the same direction. So for both force and displacement, their direction is to the right. So for this specific case, itong case that we have here, the work done by the force is equal to this equation here. Work W, that is our symbol for work, is equal to the force times the displacement S. So by the way, things to note here, yung work done is attributed to a force. So we don't say that this is the work done by the person. Ang sinasabi natin dito, this work done here is done by this force F. So that is one thing to learn about work. Work in physics is always attributed to a force. Hindi dun sa object applying the force. No? So what is doing work is the force itself. Now this is our equation for work done. By the way, the SI unit for work is joule, which is equal to 1 Newton times meter. So, yan yung unit natin for work done. So, if we look at our equation here, we can see the factors contributing doon sa work done by a specific force. First, yung magnitude ng force. Gaano ba kalakas yung force na in-exert natin? And second is the displacement. Gaano kalayo yung na-cover na distance ng object as it is moving. Now, so, from here, we can see that your work done occurs when a force causes a displacement. This means na kung walang displacement yung object, wala tayong work done. So, for instance, if you have a person carrying an object, pero hindi nagmo-move yung object, the person is exerting a force F doon sa object in order to hold it up. Pero since hindi nag-move yung object natin, walang displacement, this force na in-exert ng ating person does not do any work. Walang work dito. Or say you have a person pushing a box against a wall. Now, since the box is not moving, walang displacement yung ating box, then no work is done by our force F here. Or say, you have a person that is walking, so nagmo-move na yung person while carrying a box, tapos it is exerting a force F on the box. Now, even though the person is moving, magkakaroon ng displacement dito for the box. But since it is not specifically, hindi itong force na ito ang nag-cause ng displacement, so wala pa ring work done. If we go back sa ating statement kanina, work occurs when a force causes a displacement. So kahit may force na in-apply, pero hindi siya ang nag-cause ng displacement, hindi dahil sa kanya, bakit nag-move yung object, then the work is still 0. So again, even for this case, merong force applied doon sa box, pero clearly hindi itong force na ito ang nag-cause ng displacement, then the work done by this force is 0. Another case na wala tayong work done is if there is no force applied at all. So let's say nandito lang yung person, wala siyang ine-exert na force dun sa ating box, but the box is moving, meron tayong displacement. Again, work is still 0 kasi walang force. So that is our understanding now of what is work done in physics. Work is always done by a force in physics, tapos work is done when a force causes a displacement on an object or na-move ng isang force ang object. So this is the simplest case for work done. Let's consider a more complicated case. So consider a person, again, pushing a box. But this time, yung force applied by the person is angled downwards. Again, our force is still constant, and this will result to a displacement. Tapos, katulad kanina, ang ating displacement is still a line. So in this case, hindi na pareho yung direction ng ating force at saka nung ating displacement. So how do we solve for the work done sa case na hindi sila pareho ng direction? So one thing we can do is to sketch both our vectors. So this is the displacement and this is the force F, this angle phi. Now one thing we can do here is to decompose yung ating F into two components. Now one component is collinear sa ating displacement and the other component is perpendicular sa ating displacement. So the component above, that is F cosine phi. And then this one here, this is F sine phi. So now we can treat yung force natin na F as two separate forces. Yung isang force is F cosine phi. Tapos the other force is F sine phi. Now, sabi natin kanina, if the force and the displacement is in the same direction, then the work done is simply the product of the two magnitudes. So, ang magnitude ng force natin ngayon is F cosine phi multiplied sa displacement S. Now, for the other force, there is no work done. Wala siyang contribution sa work done. Kasi clearly, from the direction, hindi siya ang nag-cause nung displacement kasi downward yung ating F sine phi. So, this component here has no contribution. Which means, this expression here is our work done for the case na the force is not in the same direction as the displacement. So work done is F cosine phi times S, or we can rearrange this, Fs cosine phi. Now yung angle natin phi, this is the angle between our force and our displacement as seen here. Now, itong expression natin na ito, Fs cosine phi, we can also rewrite this as our vector F dot our vector S. Now, itong dot na ito, this is a vector multiplication and this is what we call a dot product. So, what does a dot product do? So, precisely itong equation na ito. Now, it will multiply yung component ng F that is aligned with S to the magnitude of S. So, yun yung dot product. So, this is now our equation for case number 2 where our force is not in the same direction as the displacement. So, let's look at an example. So, let's look at this case where 5 friends are trying to push a box to a certain location. So, let's label each person. And then they are exerting the same force pero in different directions. Now, for person 2 and 4, yung force applied is angled 45 degrees from the horizontal. This is our situation. Now, again, ang forces they apply are the same. So, let's put a value. Let's say 100 newtons. So, they are now trying to push the box until such time that the displacement is, so let's say it moved to the right by 2 meters. Now, what we are interested to find out in this problem is ano yung work done by each of these forces exerted by each of the friends. So, let's begin with work done by person number 1. Now, we will use yung ating equation for case number 2. So, you have force 1 dot the displacement S. Or, this is simply equal to the magnitude ng force 1 times S times cosine phi. Now, we need to know anong value nitong angle natin, phi. So, again, this angle phi is the angle between your force F and your displacement. So, let's try to sketch muna ano yung direction ng dalawang force. So, this is your displacement. And then, yung force is actually on the same direction as well. Therefore, if you look at yung ating diagram, pareho sila ng direction, the value of phi should be 0. Kasi walang angle between them. So, let's substitute now yung ating values. Now, cosine 0 degrees, that is actually equal to 1. So, this becomes 200 joules. So, yung work done by person 1 is 200 joules. Okay? Now, let's look at person 2. So, let's take note na yung force exerted by person 2 is angled 45 degrees from the x-axis. Ganun yung direction niya. So, let's solve for the work done by person 2. Again, our equation, force F2 dot the displacement S, or this is simply equal to F2S cosine phi. Now, again, gusto nating malaman ano yung value ng phi. So, let's sketch yung ating vectors. So, you have S. Then, your force is, again, angled 45 degrees from the x-axis. So, clear na from our sketch that the angle between them is 45 degrees. So, yung value ng phi is 45 degrees. So, now, let's substitute yung kanilang values. Again, ang ating force is 100 Newton. Pare-pareho lang sila ng magnitudes. Displacement is 2 meters. And then, our angle is 45 degrees. Now, if you plug this in to your calculator, tapos round off kayo ng 2 significant figures, you should get 140 joules. So, ito yung work done by friend number 2. So, this friend here. Now, let's look at ano yung work done by friend number 3. So, itong person na ito. So, you can notice directly upward yung force exerted by this person here. So, let's try to solve for the work done by that person. So, again, our equation is the force F sub 3 dot S, or F3 S cosine phi. Again, we need to know what is the value for phi. So, let's sketch. This is our displacement. This is the direction of the force exerted by friend number 3. So, ito yung angle niya, which is actually 90 degrees. So, now let's substitute yung values. Again, we have 100 newtons for the force. Displacement is 2 meters. And then the angle is 90 degrees. Now, cosine 90 degrees, that is equal to 0. Which means, the work done by friend number 3 is 0 joules. Or wala siyang ginawang work. So, that is for friend number 3. Now, let's solve for the work done by friend number 4. So, again, yung direction niya is angled 45 degrees pero to the left. So, let's solve for the work done by that person. Again, our equation, force dot displacement, or simply F4 as cosine phi. Now, let's determine ano yung value ng phi by drawing a sketch ng ating vectors. So, this is your displacement. Now, this is F4. 4. Angle is 45 degrees from the x-axis. Now, ang value ng ating phi, we defined phi as the angle between your vectors. Now, you have two angles here. This is one angle. What we will take here is yung shorter na angle, this angle here. So, if this is 45, this angle here should be 135 degrees. So, let's substitute yung values. You have 100 newtons times 2 meters. So, you have cosine 135 degrees. Okay. Now, plugging that in sa ating calculator, again, rounding off to two significant figures, we should get negative 140 joules. So, that is the work done by friend number 4, by this person here. Next, let's try to solve the work done by friend number 5. So, yung direction of force niya is to the left. So, let's try solving the work done. Okay, this is our equation, or this is equal to F5S cosine phi. Now, let's determine yung value ng phi, that is the angle between our vectors. So, our displacement S is to the right, but our force F5 is to the left. So, the angle between them is this angle right here, that is 180 degrees. So, yun yung value ng ating phi. Plugging in our values. Now, cosine 180 degrees, this is actually equal to negative 1. So, this becomes negative 200 joules. So, now we've solved all the work done by all of the friends. So, let's analyze for a second ano yung result natin. We see here na the person who did the greatest work, pinakamalaking work done, is person number 1 with a value of 200 joules. Now, we can see that this is true because yung direction of the force applied by this person is in the same direction as the displacement. So, yun pala yung direction that produces the greatest amount of force. Now, for friend number 2, since may angle na konti yung kanyang force, then we have a lesser work done by the force exerted by friend number 2. So, mas konti na lang yung work done by the force exerted by friend number 2. Now, if we go to friend number 3 and look at yung work done ng force niya, since perpendicular sila, clearly, walang natulong yung force exerted by person 3 doon sa pag-move ng object. So, makita din natin yan sa value ng work done by person 3, 0 yung work done niya. Which means, walang natulong yung force exerted by person number 3 in moving the object. So, we see here, yung definition talaga ng work done. Work done happens if a force causes yung motion ng object. So, in this case, meron kang force, pero this force did not cause yung displacement. So, 0 yung work done niya. Now, let's look at friend number 4, which is interesting. Now, since angled to the left yung kanyang force, tapos the displacement is to the right, when we solve yung kanyang work done, we got actually a negative value. Now, what does that mean sa ating definition ng work done? If positive value means may natulong siya in moving the object, and 0 means wala siyang natulong, the negative value of work done means na instead of helping, naka-contribute pa yung force mo in preventing yung displacement. No? So, nasa opposite siya na side nung pag-help ng motion. So, you could imagine na if wala si friend number 4 dito, mas madali yung pag-move nung box. No? So, yun yung ibig sabihin ng negative work done. So, we have negative work done, but ibig sabihin nun, they are going against the motion. Hindi niya tinutulungan yung motion. And we see that more defined kay friend number 5 dahil sa angle din ng force ni friend number 5, opposite talaga siya sa motion. Na kapag tanggalin mo si friend number 5 dyan, mas madali yung pag-move nung box. Instead of helping move the object, the force exerted by person 5 is actually preventing yung pag-move nung object. So that's how we view negative values of work done. So, as an overview, we can see here that work in physics is defined by how much a force produces displacement. Ano? So nakita natin na if a force is applied, pero hindi naman siya nag-cause ng displacement, then zero yung work done niya. And we've seen also cases where the applied force is actually preventing yung displacement, so magiging negative yung value niya. That's how we define work done in physics.